Okay, so I think today's session was scheduled for, I think, capacitor, right? Okay, so we'll be
হ্যাঁ
having total 3 capacitor practice sessions. There will be a level 1 session, there will be a level 2 session, and there will be a level 3 session. And all the 3 sessions will be ensuring ki whatever problems might come in JEE Mains session 2 or your NEET, we'll try to cover each and every one of them. So we'll be breaking down into 3 sessions. If I'm not wrong, probably I had mentioned previously this session is going to be of 1 hour probably. And if I'm not wrong, I said ki Saturday night there is a comparatively lengthier session. Then I thought there is no meaning of doing this. Let's split it in the equal fashion. Okay? So let's do at least 1.5 hour for tonight. Okay? Jitna ho jayega acha. The parts which will be left, that will be doing Saturday session. Okay? There are total 19 problems in this, and all, how many are there? 19. All of these are of level 1. Okay? If we can finish this 19 problems, it will be a good practice of at least the level 1 numericals. So the level 1 numericals, the main aim is ki, just to ensure ki you have retained each and every concept, each and every theoretical points that we had discussed during the discussion of this chapter. We'll try to ensure ki all those points are actually revised. Okay? These are the problems on the EGS side. Okay? We'll be gradually increasing the level. So there will be total 3 practice sessions on this particular chapter of capacitor. Okay? Good. Ishonache? Am I audible, anyone? Chalo. Let's start anyway. Let's start with the first problem. Acha, which particular color will be better? I think if I use red over white, it will be better.
পাঠিয়ে দেবেন না লিখে নেব এখন?
লেখার কিছু নেই, আমি এখানেই মানে স্ক্রিনেই লিখতে থাকবো। তোরে যদি মানে if you guys want this particular problems, I can send you the pictures after the session. And if you guys want, just
yes sir, questions গুলো send করে দিন.
Then anyone remind me after the session once. I will be asking Arnav to send this in group. Okay, sure. Let's come back. Let's come to the first problem. The first problem says in a parallel plate capacitor of plate area A, separation D and charge Q. Okay, the force of attraction between the two plates. Guys, didn't we already derive the force of attraction between the two plates?
Yes.
Chalo, let's do it here. Huh? Achha, which color will be better? Can I use red over this white? Which particular color will be better for you guys? Confirm me. If I use red over this white, will it be
Red
better?
or blue?
Red or?
Blue.
Now, blue isn't something I will use. So let's come to red. A parallel plate capacitor of plate area A, plate separation D and charge Q, find the force of attraction. Okay, did we study something like this? In a parallel plate capacitor, the capacitor consists of 2 plates. Did we discuss something like this? If the charge on the capacitor has been mentioned to be Q, right? What is the charge on the capacitor mentioned? Q. As we know that the 2 plates of the capacitor have charges which are of equal magnitude but opposite in that of sign. So if one of the plates is having plus Q charge, the other plate will be having minus Q of charge, right? Did we study something like this? All the charges on the capacitor are present only in the inner surface. So if this surface is having plus Q charge, the inner surface of the other plate of the capacitor will be having exactly equal amount of opposite charges, right? If we had discussed this, right? The outer surface doesn't have any charge in case of the capacitor plates. Only the inner surfaces have charges. So if this is a charge of plus Q, this particular plate, the inner surface of the other plate will be having a charge of minus Q, right? ঠিক আছে তো? Yes or no? Babu, I want to calculate the force exerted between the 2 plates. So can I do it in this fashion? Let's calculate the electric field created by one of the plates on the other plate, and then just multiplied by the charge present on the other plate. That will be giving me the total attractive force which is present between the two. Ladies and gentlemen, what was the electric field created by the plus plate on the minus plate? Anyone? Was it Q by A epsilon naught, or it was Q by 2A epsilon naught? What did we see? It was Q by 2A epsilon naught, right? Because the charge is present only in one surface. So the electric field created by the positive plate is Q by 2A epsilon naught, right? It is not Q by A epsilon naught. The charge is present only on the inner plate, right? So it will be Q by 2 epsilon naught. So the electric field created by the positive plate on the negative plate is Q by 2 epsilon naught. but the negative plate is containing negative charges. Negative charges experience force opposite to the direction of electric field, right? The positive plate is creating an electric field towards right, no doubt. But the negative plate is containing negative charges. Negative charges experience force opposite to that of the electric field. So the electric field is directed towards right. So the force experienced by the negative plate due to the positive plate, it will be towards left. Yes or no? Does it? Sorry. Does it make sense, guys? Confirm me, anyone. Is it clear what we are discussing? ठीक আছে? So what will be the force experience? What will be this force F? Can I say the force F will be, just a moment. The force F will be nothing but electric field, which is E, multiplied by the magnitude of charge. What is the magnitude of charge? Q. Sir, why you are not taking minus Q? But the negative sign only gives me an idea about the direction of the force experienced by the plate, right? What is the magnitude of the charge present in this plate? It is Q. So it will be just E into Q. What is the electric field we just got? Q by 2A epsilon naught whole multiplied by Q. So will I be getting Q square by twice A epsilon naught? Yes or no? Do we have any such option? Q square by twice A epsilon naught? Yeah, this one. So Q square by 2 epsilon naught is the right answer. Any doubt, sir? Is it clear, guys? Confirm me once. Any doubt in any part? This is the electric field created by the positive plate. This is the magnitude of charge present on the negative plate. Multiplication of that will be giving me the total force exerted by one plate on the other plate. And this is the force of attraction. Yes or no? Is a voice coming clearly? Anyone please confirm me once. Can we move to the next
Yes,
one?
sir.
The next one says, the figure below shows 4 capacitors. Okay. Acha, there are 4 capacitors connected across a power supply of 310 volt. Okay. What is the charge and potential difference across the 4 microfarad capacitor? In this problem, there can be a small doubt that you'll be having. Sir, you haven't mentioned the polarity. The polarity of the power source, the polarity of the battery hasn't been mentioned. So in such a case, you can assume anything, right? The final answer is not going to be dependent on that in terms of magnitude at least. So you can start with any assumption. Chalo, main maan leta hu ki the upper one is positively charged and the niche wala is negatively charged. Clear? Anyone, any doubt up to this first? Is it clear? ठीक আছে? अच्छा. Babu, I can observe that 2 4 microfarad capacitors are present in parallel. What is the equivalent of them? Though 4 microfarad ka capacitor is present in parallel, so what will be the equivalent of that? Will it be 8? Babu, 8 microfarad, this 20 microfarad, and this 12 microfarad, are they present in series? भाई और बहनों, ये दो 4 microfarad को you can replace by a single capacitor of capacitance 8 microfarad. 8 microfarad, this 20 and this 12 microfarad, they will be present in series. Do I need to explain, or I am assuming that after at least 1 year of preparation, this much you can understand on your own only? That the 20 microfarad, 8 microfarad, and 12 microfarad are present in series. If the 3 capacitors are present in series, what will be their equivalent? 1 by C equivalent कितना होता है? 1 by C1 plus 1 by C2 plus 1 by C3. Yes or no? Solve करने में कितना आ रहा है दोस्त? This is 6 plus 15 plus 10.
So 31.
So C comes out to be 120 by 31. So does it mean, guys, this whole network, this complete network can be replaced by a single capacitor of capacitance 120 by 31 microfarad? Can I imagine? Can I think in this fashion? Yes or no? This whole capacitance, this whole combination can be replaced by a single capacitor of capacitance 120 upon 31 microfarad? Yes or no? I'm erasing this one, huh? I will be writing here. So I can observe this network can be replaced by a small equivalent network where across 310 volt, a small capacitor of capacitance, just a single capacitor of capacitance. What did we get? 100. Anyone, what did you get? 120 by 31 though. Anyone confirm me once? Did you get this 120 by 31? 120 by 31 microfarad is placed. Okay? Now, what will be the charge coming out from the positive terminal of the battery? आप बोलोगे simple sir. Q equal to क्या होता है? C into V. What is the potential difference across this single capacitor? Same as the EMF of the battery, 310 volt. So what will be the charge present on this particular capacitor plate? C into B, 120 by 31 into 310. कितना आएगा दोस्त? 1200 microfarad.
हाँ सर.
Will it be 1200 microfarad, guys? Anyone confirm me once? Will it be 1200 microfarad? इसका मतलब जो positively charged वाला plate है, how much charge will be present in that plate? 1200 by 31 microcoulomb. And the other one will be having minus 1200 by 31 microcoulomb. Seriously.
No.
That's what your calculation tells you. So then why you are saying yes and yes? Yes bolchis কেন তোরা? So I'll be getting 1200 microcoulomb, right? So this particular plate is directly connected to the positive terminal of the battery. So this 1200 microfarad is directly coming from the positive terminal of the battery. Yes or no? Clear? So let's come back to this figure. Positive terminal of the battery say how much charge has come. What did we get? 1200 microcoulomb. So what is the charge on this particular plate? इस प्लेट में चार्ज कितना होगा? अच्छा, I know कि the charge is present only on the inner surface. Just because of the lack of space, I am writing the charge here. ठीक है? 1200 microcoulomb. Yes or no? Anyone confirm me? Is it 1200 microcoulomb? So what will be the charge present in this plate? Will it be minus 1200 microcoulomb? Yes or no? Everyone, is it clear? But whatever charge is given, whatever charge is delivered by the positive terminal of the battery, do we know something like this? Is the same charge enters the negative terminal of the battery? Yes or no? তো কি আমরা জানি তো, তাহলে নেগেটিভ টার্মিনাল অফ দ্য ব্যাটারিতে কত চার্জ ঢুকছে? How much charge is entering the negative terminal of the battery? Same 1200 microcoulomb? Or in other words, can I say in this way, whatever positive charge is delivered by the positive terminal of the battery, exactly equal amount of negative charge is delivered by the negative terminal of the battery. So how much negative charge will be delivered by the negative terminal of the battery? Same as 1200 microcoulomb. So can I say this negative charge will be deposited in this particular plate? तो इस प्लेट में कितना चार्ज आएगा? -1200. तो इस प्लेट में कितना आ जाएगा? Will it be +1200 microcoulomb? Confirm me once. Any doubt up to this? Have we been able to do it right? Yes or no? Babu, look at this particular plate. Achha, let me use another color. Look at this plate, look at this plate, and look at this plate. Can we say these three plates are collectively isolated from the rest of the circuit? Can we say the three plates are collectively isolated from the rest of the networks? So what should be the sum of charges of these three plates? 0. तो अगर इस प्लेट में -1200 microcoulomb है, what is the sum of charge present in this plate and this plate? +1200 microcoulomb. Are the two capacitors are having exactly same capacitances? Yes, sir. So can I say the 1200 microcoulomb charge will be shared between them? So it will be having +6000 and this will be having 600 microcoulomb. Does it make sense up to this? अगर ये +600 में है, this will be having -600. If this is having +600, this will be having a charge of -600. ठीक है? Have we been able to find out the charge present on each and every plate? No. The question is just asking what is the charge and potential difference across the 4 microfarad capacitor. 4 microfarad में charge कितना होगा दोस्त? 600 microfarad. और Q equal to क्या होता है? C भी, तो V will be Q by C. 600 by 4 कितना देगा मुझे? Will I be getting 150 volt? Microcoulomb by microfarad gives me volt unit. So is this going to be the answer? Anyone confirm me once? 2C is the answer. Yes?
Yes, sir.
But the third one is something that we had already derived in class. Didn't we already derive this in class? Do I need to do it again? Or you guys know this? आप बोलोगे no sir, we haven't derived this. इधर थोड़ा सा different, कुछ different लिखा है इधर. What different is given here? Your answer will be, sir, the one that we had derived in class that was a spherical capacitor. तो मैं बोलूँगा isn't it spherical capacitor? अब बोलोगे हाँ सर, मतलब this looks like a spherical capacitor, but there is an extra point given here. The two are connected by a copper wire. So the one that we had derived in class, उधर तो सर दो capacitor plate के बीच I was having just dielectric material. Do I have a dielectric material between the two plates of the capacitor here? No sir. Instead of that, what do I have? So the two are connected by a copper wire, sir. Very good. What does it mean? Sir, so the two plates are connected by a copper wire. So sir, it simply means that the two plates will be present at equal potential. अरे भाई वो तो मेरे को भी मालूम है. That much I also know that the two plates will be at same potential because they are connected by copper wire. My answer is what is the implication of that? मतलब इसका meaning क्या होगा? What will be the effect of that? Anyone? What will be the effect of that? Quick. I'm giving you 1 minute to think. Anyone? I'll be very happy if someone can explain. Anyone? क्या
একটা স্পিয়ার হিসেবে কাজ করবে,
কি হবে?
একটা স্পিয়ার হিসেবে কাজ করবে।
And why so? What is the reason? Anyone? If two plates are connected by a copper wire, the two plates will be at same potential. We know if any two metallic bodies are connected by a conductor, they will be having exactly equal potential. That's the only basic that we know. Now my question is, uska implication kya hoga? That's simply what I am asking. I'll be very happy if someone can explain, guys. Whatever comment you have made, I need an explanation of that. If someone is saying that the two will be behaving like a single capacitor, sorry, what is it? Single conductor. My question is, how did you know? How did you reach that particular conclusion? Anyone else? Jaldi. Acha, tell me something. Can anyone explain me matlab, whether there will be any charge present in the inner conductor or not in this particular case? जो inner spherical conductor है, will there be any charge on this or there will be no charge on this? मतलब let's say I have given some charge to the system, ठीक है? चलो मान लो कि you have given some charge Q. Let's say you have given some charge Q to the system. Now my question is, anyone? Now my question is, will there be any charge present on the inner sphere or there will be only charge present on the outer sphere? And if whatever you are saying, you have to prove that. So chalo, let's assume something. Let's assume I have given some charge Q to the system. Okay? I don't know how much charge will be in the inner conductor. I don't know how much charge will be in the outer conductor. So chalo मान लेते हैं कि out of Q amount of charge, let's say Q1 amount of charge is present on the outer sphere, and let's say Q minus Q1 amount of charge is present in the inner sphere. ठीक? एक छोटा सा डाउट हो सकता है ब्रेन में. Sir, tell us one thing. Is this Q1 charge present in the outer surface of the outer conductor or in the inner surface? Bhai, I don't know. All I know is I have given a charge Q to the system, and I'm assuming out of this Q amount of charge, let's say Q1 amount of charge resides on the outer sphere, and the rest of the charge Q minus Q1 is present on the inner conductor. Is it clear what I'm saying? Does it make sense? Now, ladies and gentlemen, what is the potential of the inner sphere? What is the potential of the inner sphere? Well, let's take a point on the surface of the inner sphere and tell me what is the potential of the inner sphere.
Same as
Babu,
that.
because of its own charge, there has to be a potential. What is the potential at the surface of the inner sphere because of the charge that is present on the inner sphere? Will it be K into charge present on the surface divided by radius? Yes or no? Plus, will there be any potential on the inner sphere because of the outer sphere? अब बोलोगे सर ना. मैं पूछूंगा क्यों? Why you are saying no? Absolutely there will be a potential. भाई electric field zero होता था, potential wasn't zero. Do you remember this? Did we study something like this कि if there is an uniform spherical cell, इसका inside में हर एक point में potential used to be same because of its charge. So because of the Q1 charge present in the outer sphere, what will be the potential at any point on the inner sphere? आप बोलोगे it will be K into the charge present on the outer sphere, which is KQ1 divided by B. I'm hoping कि by after 1 year you have been able to retain the results. Okay, unless someone is completely shameless, he or she will not be saying कि sir I haven't been able to retain after 1 year of preparation. Okay, चलो. Anyway, guys, what is the potential now? Tell me on the outer sphere. What is the potential of any point on the outer sphere? अब बोलोगे सर if you take any point on the outer sphere, एक तो potential होगा because of itself, because of its own charge. How much potential will be there? Same kq1 by b. I don't need to explain. Plus because of the charge on the inner sphere, what will be the potential at this point? K into q minus q1 by smaller, the distance from the center. What is the distance of this point from the center, guys? Is it b? Yes or no? Any doubt up to this? kq1 by b, kq1 by b cancelled. আসছে kq1 by b, kq1 by b cancelled. Yes or no? So k and k gets cancelled. So I am getting q minus of q1. Take this on one side into 1 by a minus 1 by b equal to 0. This term cannot be 0. So that means q has to be equal to q1. Q minus q1 has to be equal to 0, or q has to be q1. But if q equal to q1, then what is the charge on the inner sphere? 0, sir. Why? Sir, we only got na q equal to q1. What does it mean? Sir, if q equal to q1, that means sir, the charge on the inner sphere is 0. Very good. So what is the charge on the outer sphere? Sir, q1. And what is q1? Sir, the total charge that you had given. Very good. So what is the charge on the outer sphere? Q. So have we been able to prove, ladies and gentlemen, that in this particular case, there will be no charge present on the inner sphere. The complete charge will be placed on the outer sphere only. Ladies and gentlemen, if there is no charge placed on the inner conductor, is there any meaning of having the inner conductor? Is there any significance of the inner conductor? No, sir. So what do you conclude finally? Sir, we can conclude sir, there is no inner conductor. Very good. So there is only the outer conductor. Yes. So if there is only outer conductor, can I say the system behaves like an isolated spherical conductor? A single isolated spherical conductor? एक isolated spherical conductor का what used to be the formula of its capacitance? Sir, 4 pi. Sir, you haven't mentioned any dielectric medium. No, sir. So, sir, epsilon naught into its radius. What is the radius of the outer sphere B? So, this is the capacitance of the system. Any doubt, sir? Guys, we have proved this. Okay? We have proved that there will be no charge present in on the inner conductor. Clear? I could have directly told you, I could have directly given you a statement that there is no charge on the inner conductor, but we have been able to prove mathematically that in this case there will be no charge present on the inner conductor. The complete charge will be present only on the outer conductor. And what will be the capacitance of the system? It will be 4 pi epsilon naught b. Any doubt? Am I audible, guys? Is the voice coming clearly? Anyone confirm me once? Okay. Easy problem. Which option then? C. C is the right option, right? Chalo. Next one is to probably cakewalk for you. Anyone? What is the answer? What is the answer, sir? Answer क्या होगा? Quick, guys. Guys, what is the equivalent capacitance of this combination? Anyone? Don't hesitate. Like most of you know it right only. What's the meaning of not giving answer?
C by 3 হবে।
A by, matlab you mean C by 3. Okay, I have got one answer. What about others?
2C হবে।
Anyone else other than
2C.
Moyuk?
2C.
Chalo. See, Babu, look at this particular terminal. This terminal is connected to this. This terminal is also connected to this. So whatever is the potential is that terminal, चलो मान लेते कि इसका potential is V. So the potential of this terminal V, potential of this terminal V. So what is the potential difference across this capacitor? 0, sir. But if the potential difference across this capacitor is 0, then what is the charge present on this capacitor? 0, sir. If there is no charge present on this capacitor, can we replace this capacitor by a short circuit? No, sir. क्यों? सर चार्ज नहीं है तो ओपन सर्किट कर दो ना सर. चलो ओपन सर्किट करते हैं. If there is no charge, can I just remove this from the figure? We have been able to prove that there is no charge present on this. If there is no charge present on the capacitor, is there any significance of keeping this capacitor in the picture? No, sir. So will it be okay if I just remove this capacitor from the picture? Yes, sir. So chalo, let's draw the equivalent circuit. Let's draw the equivalent circuit by removing this capacitor. CNC parallel में क्या आएगा दोस्त? Anyone? 2C. ठीक है? Good. What about the next one? Is it a Wheatstone bridge? Anyone? Is it a Wheatstone bridge? I want the answer in yes or no. It's a Wheatstone bridge or it is not a Wheatstone bridge.
No, sir.
No, sir.
But you understand, मतलब the problem with you people is যখন 1 year ধরে মানে কি আর বলবো, but anyway. Babu, have I asked the question if it's a balanced Wheatstone bridge or if I have just asked the question if it's a Wheatstone bridge? What is the question I asked? The question I asked was if it's a Wheatstone bridge or not. Arey bhai aur behno, it's a Wheatstone bridge. I haven't asked you whether it's a balanced Wheatstone bridge or not. That was not the question. This figure is Wheatstone bridge. Question to sun le beta. Everyone is giving the answer of the question whether it's a balanced Wheatstone bridge or not. That's not what I asked. I asked if this is a Wheatstone bridge or not. It's a Wheatstone bridge? Yes. Is it a balanced Wheatstone bridge? No, sir. It's not a balanced Wheatstone bridge. The balanced Wheatstone bridge nahi hai. That's okay. But this is definitely a Wheatstone bridge. Okay? Anyone just draw the equivalent diagram of this? Let's draw the equivalent diagram of this. What is the equivalent circuit diagram? Matlab, just draw it in the normal fashion. This is A. एक बार check कर लेना. If I make any silly mistake, just let me know. This is 3 microfarad. I haven't got any rest since last night. तो मेरा cognitive ability थोड़ा सा declined at this moment. ठीक है? 3 microfarad, 6 microfarad दोनों के बीच. What is connected there? 3 microfarad. कि ठीक है तो? I'm hoping you can understand how I'm drawing this. After 1 year of preparation, this is 6 microfarad, and you have another 3 microfarad here. Here, yes or no? This is terminal B. Anyone confirm me? Have I drawn it right? Oh, does this figure have any kind of symmetry? Did we give a name to that symmetry? This figure has a symmetry, right? Anyone? What is the name of this symmetry? Binit? Or Godif?
Diagonal symmetry.
There is a diagonal symmetry here. That's exactly. Taito, hopefully I don't need to explain. 3 microfarad, 3 microfarad, 6 microfarad, 6 microfarad. We do have a symmetry in the figure, and the symmetry is a diagonal symmetry in the figure. Yes or no? Anyone? Am I having a diagonal symmetry in the figure? Okay. Did we already solve this problem in class? When we have been doing the foundation sessions, when we had started this chapter, during the foundation class only, we had discussed this. Whenever we are having diagonal symmetry, how to proceed? Do you guys remember? Can I assume that you guys remember the result? Chalo. Did we? Chalo, let's not use any shortcut. Let's do in the normal fashion. Let's say there is a battery connected of EMF B. मान लेते कि this is sending a charge of plus Q. Anyone? How much charge will be deposited here? इस प्लेट में जहाँ चलो Q1 जाएगा. चलो मान लेते हैं कि let's assume कि in this
shortcut হয় না.
হয়. But that particular batch where 50% doesn't remember a term called diagonal symmetry, they don't deserve to know the shortcut. So this is Q1, this will be minus Q1. This 3 microfarad and this 3 microfarad are will be having same charge. Did we prove this previously? इसमें Q1 minus Q1 है तो this one will be having also Q1 minus Q1. Total कितना charge आ रहा है? Q1 amount of charge is going there. So the rest of the charge will be going here. So how much charge will be here? Q minus Q1. तो इसमें कितना charge होगा? Negative of that Q1 minus Q. In this two there will be same charge. কি same charge হবে তো নাকি অন্য charge হয়? Brothers and sisters, same charge হবে তো নাকি? Yes or no? If Q minus Q1 is present in this particular plate, didn't you already prove previously? इस प्लेट में भी चार्ज होगा Q माइनस Q1 और इसमें चार्ज होगा Q1 माइनस Q. Yes or no? Anyone confirm me once? Look at this particular plate, look at this particular plate, and look at this plate. Are these three plates collectively isolated from the rest of the network? Yes, sir. So what should be the sum of charges in these three plates? Anyone? Should it be zero? So to make the sum of charge zero, how much charge should be present in this plate? 2Q1 minus Q. So 2Q1 minus Q इधर होगा तो नीचे वाला प्लेट में चार्ज कितना होगा सर? Q minus 2Q1. Yes or no? Have we been able to write the charge distribution throughout the network? Yes or no? Clear? Now to find out the equivalent capacitance, what did you use to do? Did we just try to calculate the ratio Q by V? If Q charge is coming out from the positive terminal of the battery and if the EMF of the battery is V, did you see that the C equivalent will come out to be equal to Q by V only? So we have to basically calculate the ratio Q upon V. Right? Is it making any sense? Clear हो रहा है दोस्त? Yes or no? ठीक है? बाबू write a KVL in this outer loop. ये जो outer loop है ना, write a KVL in this loop. बोल क्या आएगा KVL? I am directly writing here. I am assuming after this much preparation, I don't need to explain how I am writing KVL in a capacitive network. ठीक है? Those days are gone, baby. तो इधर से इधर आओगे तो V होगा, इधर से इधर आओगे तो माइनस Q1 by 3. उसके बाद माइनस इधर से इधर आओगे तो which plate you are hitting first? Q minus Q1 divided by 6. Anything else? No. We come back to the same battery. So this comes out to be equal to 0. Have we done it right, guys? Anyone confirm me once? ARI equation. Outer loop में A आ रहा है या नहीं आ रहा है? Please anyone confirm me once. Are you getting this? The outer loop. ठीक है. Good. Which particular variable do I need to get rid of from this equation? I need to get rid of this Q1, right? I have to write everything in terms of V and Q only. So if I have to get rid of Q1, I need a relation between Q and Q1. To get a relation between Q and Q1, I need another KVL equation. तो कोई भी एक दूसरा loop पकड़ लो and write a KVL equation. चलो, we'll be writing the KVL equation in this loop. ठीक है? Good? Any doubt? কি বলছি কিছু clear হয়েছে? We'll be writing the KVL equation in which loop? We'll be writing the KVL equation in the inner loop, right? Chalo, let's write the KVL equation in the inner loop. Chalo, let's write here. Let's start from this particular point. If you move from here to here, what will be the change? Minus of Q1 by 3. If you move from here to here, what will be the change? Minus of which plate you will be hitting first? 2Q1 minus of Q divided by 3. So we will check if I am making any calculation error, please let me know immediately. If I move from here to here, what will be the change? Minus of which plate you will be hitting first? Q1 minus Q. So Q1 minus of Q divided by 6 equal to 0. Anyone confirm me once if I am getting this or not? Have I written it rightly, or if I made any kind of silly mistake while writing this, please let me know. Okay, my cognitive abilities have been compromised because of lack of sleep for last 48 hours actually. Have I been able to write it correctly? Yes or no? Please confirm me.
Yes, sir.
चलो इसको थोड़ा सा सिंप्लीफाई करते हैं. लेट्स मल्टीप्लाई बाय 6. ठीक है, 6 से मल्टीप्लाई करेंगे तो क्या आएगा दोस्त? इफ यू मल्टीप्लाई दिस बाय 6, चलो इधर लिखता हूं. आई विल बी गेटिंग माइनस ऑफ 2Q1, उसके बाद माइनस ऑफ 4Q1 प्लस 2Q minus Q1 plus Q equal to 0. Anyone confirm me? If I multiply by 6, is this what I'll be getting? Yes or no? Everyone good? Minus 2Q plus 2Q is cancelled. So am I getting Q equal to minus 4Q1 minus 5Q1? Am I getting Q equal to 5Q1? Anyone confirm me once? Am I getting Q equal to 5Q1? Yes or no? Everyone is getting the same result?
Yes,
Okay?
sir.
Now in this equation, let's replace Q1 by Q by 5. So what I'll be getting? V minus Q1 के place में लिख दो Q by 5. So Q by 15 minus Q minus, what is Q1? What is the value of Q1 I got? Q by 5 divided by 6
Yeah,
equal
sir.
to 0. Key.
ওই 2Q-টা তো 2Q1 ছিল।
2Q-টা 2Q1 ছিল। Which one?
মানে ওটা ক্যান্সেল হবে না, যেটা
ও
ক্যান্সেল
সরি, তাহলে এত তো আমি কতক্ষণ আগে বলেছিলাম রিমাইন্ড করাতে, এখন বলছিস কেন তাহলে? আমি বলেছিলাম whenever I am making a calculation error, immediately pause me. So if you multiply this by 6, what you'll be getting? Minus of 2Q1, उसके बाद minus of 4Q1 plus 2Q minus Q1 plus Q equal to 0. चेक करो ने, ठीक है दोस्त? 2Q plus Q 3Q, yes or no? 2Q1 4Q1 Q1 7Q1, एक बार चेक कर, আসছে এটা? Check and confirm you guys, then I'll proceed. Vinit, are you getting this? Anyone confirm
Yes,
me?
sir. 3/7Q.
Guys, everyone is getting the same result, 3Q equal to 7Q1. Chalo. So let's replace Q1 by 3Q by 7. So how what will be getting? V minus Q1 के place में let's write 3Q by 7 whole divided by 3 minus Q minus what is Q1? 3Q by 7 whole by 6 equal to 0. Simplify करेंगे तो क्या आएगा? 3 gets cancelled. V minus Q by 7. How much is this, guys? 4Q by 42. 4Q by 42 मतलब 2Q by 21. Anyone confirm me? Am I getting this? Is this what we are getting? So V minus 21 5Q equal to 0. So Q by V equal to क्या आ रहा है? 21 by 5. Q by V is coming out to be 21 by 5. So 21 by 5 microfarad. ठीक है? This is not a problem that we have been doing for the first time, right? We have done this in basically two possible ways previously. So I'm hoping कि you're not learning this for the first time. If you are learning this for the first time, this is high time you can check your preparation. Okay? You are not supposed to do this for the first time. This was discussed during your foundation classes only. Yes or no? Any doubt up to this? There is a shortcut for doing this that we'll be doing very soon. But this can be done using a shortcut. But first tell me, is it clear? Have you been able to understand? Any doubt in any step, please to ask. ठीक है? Guys, is this just a moment? Are you being able to read this, or this is completely illegible? Legible है ना? Otherwise, I'll be writing somewhere else. Are you being able to read it properly? Anyone confirm me? If you are having any issues, I'll be doing somewhere else. The reason I have been doing this here only, because it will be easier for you to just check the problem and do the solution side by side. Okay? Otherwise, I have to scroll up and down continuously. Okay? Good. So Q by V is coming out to be 21 upon 5. So let's move to the next. The figure shows a Keiko problem. Anyone? Figure shows a circuit of 4 capacitors. Find the effective capacitance between X and Y. Quick. Done? Quick. बहू इस पॉइंट को नाम दे रहे थे A, इस पॉइंट को नाम दे रहे थे B. ठीक है? This point and this point, are they connected by a pure conductor? Yes, sir. So whatever is the potential at this point, will I be having the same potential at this point as well? Yes or no? If the potential, everyone makes sense? Whatever is the potential at this point, will be having the same potential at this point as well. So if this point is B, can I just treat this point B as B as well? Arey bhai, the 2 points are connected by a pure conductor. Whenever 2 points are connected by a pure conductor, they will be equipotential. They will be having exactly the same potential. So whatever is the potential at this point, I'll be having exactly the same potential at this point as well. So if I am naming this point B, can I say this point is also B only? Yes or no? Any doubt? Clear? So Babu, look at this 1 microfarad and 1 microfarad. This 1 microfarad is connected between A and B. Look at this 1 microfarad. This is also connected between A and B. So both of these 1 microfarads are connected between the same two terminals A and B. If both the 1 microfarads are connected across the same two terminals A and B, can I say this 1 microfarad and this 1 microfarad are actually connected in parallel? Yes or no? Can I say, guys, the two 1 microfarad, these two 1 microfarads are connected in parallel? Yes or no? Quick. Anyone confirm me once? These two 1 microfarads are connected in parallel. Oh, if these two are connected in parallel, can I replace these two 1 microfarad capacitors by a single capacitor of capacitance 1 plus 1 equal to 2 microfarad? So let's draw the equivalent circuit. I'm doing it here. Let's do it here only. So between this point and this point, instead of writing 2 1 microfarad, I can just write there equivalent. What is the equivalent? 1 plus 1, 2. So let's replace this 2 1 microfarad by a single capacitor of capacitance 2 microfarad. Yes or no? ठीक है? In 2 microfarad के साथ the other 2 microfarad is present in. Guys, look at the figure and tell me now which 2 microfarads are the 2 microfarads connected in series. 2 microfarad, मतलब two microfarads are present in series. So what will be the equivalent? 1 microfarad. 1 microfarad and 1 microfarad, they are connected in parallel. So what will be their equivalent? 1 plus 1, 2 microfarad. Yes or no? So the final answer will be 2 microfarad. Any doubts, sir? Have you been able to understand, or I will do it again? ठीक है दोस्त? Have you been able to understand? Yes or no? बताओ बेटा और बेटियों, have you been able to understand? Otherwise I will move to the next problem. ठीक है? Hey, why are you guys mute? Silent क्यों हो
Yes,
दोस्त?
sir.
I haven't been able to sleep for last 48 hours because of things in my life. But थोड़ा तो आराम से आशीष. ठीक है? Show some energy at least. चलो. 3 capacitors are connected with the source of electromotive force E as shown in the figure. Then the energy delivered by the source. But what is the formula for energy delivered by the source? Energy delivered by source का formula क्या होता है? EMF of the battery, which is E, multiplied by the charge coming out from the battery. If the charge coming out from the battery is Q, then what is the formula for energy delivered by the source? Is it E into Q? Yes or no? Yes, sir. EMF multiplied by the charge which is coming out from the positive terminal of the battery. So what am I supposed to calculate here basically? E though is already given. So from this question, I am basically supposed to calculate how much charge is being delivered by the positive terminal of the battery, right? Whatever charge is delivered by the positive terminal of the battery, that's nothing but Q for me here. Brothers and sisters, am I making any sense? If not, then what had you been doing for last 1 year? Babu, there are two Cs which are connected in series. What will be their equivalent capacitance? Let me draw it here. C by 2. C by 2 and C connected in parallel. Okay. C by 2 and C are connected in parallel, right? C by 2 and C are connected in parallel. What will be their equivalent? C by 2 plus C, which will be 3C by 2. Yes. So can I replace these two capacitors by a single capacitor of capacitance 3C by 2? Yes or no? Clear? Brothers and sisters, what is the potential difference across this capacitor? E. So what will be the charge on the positive plate? Capacitance into potential difference across the capacitor. What is the potential difference across the capacitor? Same E. So how much will be the charge on the positive plate? 3C by 2E, और नेगेटिव प्लेट में माइनस 3C by 2 into E. ये चार्ज आया कहां से दोस्त? This charge was delivered by the positive terminal of the battery. So how much charge is coming out from the positive terminal of the battery? 3C by 2 into E. So what is Q for me? 3C by 2 into E. Formula क्या था दोस्त? C into E ने की चलो formula बोल Q into E. अरे एटाई तो formula चलो ना कि energy delivered by source, charge delivered by the positive terminal of the source multiplied by the EMF of the source. How much charge is coming out from the positive terminal of the source? What did we just get? 3C by 2 into E multiplied by E. So will I be getting 3 by 2 C is square? This will be the answer. 7A. Any doubt, sir? Have we been able to understand, sir? This is a level 1 revision that we have been doing. Okay. If see, be honest with you, at least to yourself. If you're struggling with level 1, that means it's high time you make a proper revision from the active recall. Okay? You're not supposed to be stuck at this level of problem. That's just level 1 problems to ensure that each and every concept that we had discussed during our foundation sessions, those are being revised at least once. Okay? Chalo. Can you move to the next one? Any doubts, sir? In any part, I'll be discussing again. Otherwise, we can proceed. Chalo. Let's move to the next one.
স্যার এই কোয়েশ্চেনটা দেখে সিলি মিস্টেক হয়ে গেছিল ফার্স্ট।
হ্যাঁ, মানে কারো যদি সিলি মিস্টেক হয় তাহলে ভগবানও তাকে বাঁচাতে পারবে না, ঠিক আছে? So this is in your hand, guys. If you are making silly mistake after this level of preparation, the only suggestion is, मतलब कुछ suggestion है नहीं मेरे पास. See, I can give you thousands of मतलब so-called reasons, मतलब thousands of ways to reduce silly mistake, but speaking honestly, nothing will work. The only thing that will work is when you are writing tests at home, थोड़ा सा ज़्यादा cautious बनो, ठीक है? That's the only suggestion. Otherwise, YouTube में मिल जाएगा videos like 1000 ways to reduce silly mistake. Let's be honest, nothing works. ठीक है? If the silly mistake का solution एक ही है, when you are writing tests at home, थोड़ा सा cautious रहो, ठीक है? Gradually, it will be coming, it will be better with more and more tests, with more and more revision. ठीक है? चलो. Parallel, हाँ बोल.
ওই কোয়েশ্চেন 7 এ আমরা হাফ সিভি স্কয়ার ইউজ করতে পারতাম না?
Half CV square is formula of what? Which formula is half CV square?
ওখানে ওটা এনার্জি স্টোরড অফ রাইট
In what?
ইন
In capacitor. What is the question?
এনার্জি ডেলিভার্ড।
A parallel plate capacitor having dielectric slab of epsilon r equal to 6 is connected across a battery and charge. This dielectric slab is then removed and a new dielectric slab of relative permittivity 10 is introduced. Acha, haan, chalo, cakewalk problem again. Let's do this. কোথায় করব? এখানে করি নাকি? We have some space here. Let's do it here. So they say that there is a parallel plate capacitor. Okay, let me draw a parallel plate capacitor. A parallel plate capacitor is there. Okay, is connected across a battery. Acha, is connected across a battery. Okay, is connected across a battery and charge. Chalo, charge kar lete hain. What's the big deal? Chalo, let's assume ki the EMF of the battery is nothing but E, and this is filled with what is filled? It's filled with a dielectric slab of relative permittivity 6. Very good. Ladies and gentlemen, key, do I need to explain anything? No, you don't need to. How much charge will be delivered, guys? How much charge will be delivered? अच्छा चलो मान लेते हैं कि area of cross section is A. चलो मान लेते हैं कि separation is D. So what is the capacitance of this capacitor? If this had been an air-filled capacitor, then the capacitance would have been A epsilon naught by D. But it is filled with a dielectric material of dielectric constant 6. So the capacitance has to be multiplied by 6. Yes or no? एटा ही है तो भाइयों और बहनों epsilon ना लिखे in case of instead of epsilon naught I am supposed to write epsilon into epsilon r in this case, right? Because it is filled with a dielectric material of dielectric constant 6. ठीक है? So how much charge will be delivered, guys? What is the potential difference across this capacitor? The potential difference across the capacitor is E, right? Capacitance of the capacitor is known to me. So how much will be the charge on the positive plate? How much will be the charge on the negative plate? Anyone? I am drawing this capacitor by zooming in here individually. किस प्लेट में चार्ज कितना आएगा? Capacitance is epsilon naught by D into 6 multiplied by E. So what will be the charge in this plate and what will be the charge in this plate? Displacement charge कितना आएगा? A epsilon naught by D into 6 multiplied by E, right? और एटाই तो হবে the negative of that. Minus of A epsilon naught by D into 6 into EMF. Have I done it right till now? Okay, now it says that dielectric slab is then removed. Acha. So initially this was the charge, right? Initially this was the charge. Now they say that dielectric slab is now removed. Very good. And a new dielectric slab of, so what's the big deal? So I'll be doing exactly the same process now only. And এবারও তো same process করব. The dielectric slab is then removed, right? But is the battery still connected or the battery is not there? They have said connected across a battery and charge. Have they mentioned anywhere, guys, that the battery is removed? Have they mentioned anywhere that the battery is removed now? Yes or no? Has anywhere this thing been mentioned in the question that the battery has been removed after charging? Hello? It says that connected across the battery and charge. Do you see anywhere it is written in the problem that the battery is removed? No, it is not written. इसका मतलब battery, इसका meaning है battery is still there. Only the dielectric slab is removed, right? So those of you who are thinking, acha, we had done this problem, the battery was removed. No, the battery is not removed. Nowhere it has been mentioned in the problem that the battery is removed. So you cannot assume. इसका मतलब the battery is still there, just that the dielectric slab is now replaced by a new dielectric slab of relative permittivity 10. So tell me, what will be the new charge? अब बोलोगे simple, sir. Wow, we had 6 last time. This time instead of 6, I'll be having 10. Ki 10 হবে নাকি? Yes or no? Babu, it hasn't been mentioned anywhere that the battery is removed. Okay? There is a small doubt that students have here. It's given and charge, but they haven't mentioned it explicitly whether the battery is removed or not. If they don't mention whether the battery is removed or not, you and me will not be assuming that the battery is removed. Is it clear? We are not going to assume that the battery is removed. Unless and until they mention that after charging the battery is removed, I will not be assuming from myself that the battery is removed. So I will to solve the problem assuming that the battery is still there. So इस बार charge कितना हो जाएगा दोस्त? A epsilon naught by D into 10 into epsilon into EMAP, और इसमें आएगा minus A epsilon naught by D into 10 into E. Clear? अब वो एक काम करते हैं, जो A epsilon naught by D है ना सर, इसको C naught ले लेते हैं, ठीक है? बार बार I don't want to write this A epsilon naught by D, इसको C naught मान लेते हैं. Can I assume it C naught? इधर भी ये जो A epsilon naught D है ना सर, इसको C naught मान लेते हैं. ये जो A epsilon naught by D है ना सर, इसको C naught मान लेते हैं. Have I done it right? Yes or no? Clear? Now tell me, what have they asked? अच्छा, ratio of energy. बोल. What is energy in this case? Can I use Q square by 2C? Q कितना है मेरा? C naught into 6 into EMF square by 2 times of capacitance. What was the capacitance in this case? 6 C naught. Yes or no? Key. 6 C naught divided by what in the other case? This time the charge is Q square by 2C C naught into 10 into EMF square divided by 2 into C. What is capacitance this time? 10 C naught. Hopefully I don't need to explain कैसे हो रहा है. C naught cancel, epsilon naught cancel. इधर भी एक सेकेंड C naught था ना, हाँ, एक C naught cancelled. अच्छा, 2 cancel, तो न्यूमरेटर में रहेगा 6 square by 6 which is 6 by 10 square by 10 which is 10. So the answer will be 3 by 5. है क्या आंसर में 3? हाँ, 3:5 is the answer. Any doubt? Is it clear, guys? Some of you, I know from here only, some of you had been solving this problem assuming that after charging the battery has been removed. But has it been mentioned anywhere explicitly that the battery is removed after charging? No, it hasn't been. So if they are not mentioning explicitly that the battery has been removed, you cannot assume it from your own that the battery is removed. So I will assume the battery is still there, just that instead of epsilon r equal to 6, this time I am having epsilon r equal to 10. So see, I didn't do the derivation for the charge in this case. I just did the derivation for the charge calculation in this case, and the only thing I have to do is I'll be replacing 6 by 10. That will be giving me the charge in this case. Uske baad, for the formula for energy stored, it is q square by 2c. I have done that. Any doubts, sir? Am I audible? Voice just anyone? Please confirm me once.
Yes, sir.
Sure. Let's move to the next. Cakewalk problem, but this could have been a silly mistake in the exam, because we had done those problems jahan charge karne ke baad the battery was removed. Anyway, let's come to the next. Two identical metal plates are given positive charge Q1 and Q2. Okay, if they are brought close together to form a parallel plate capacitor with capacitance C, the potential difference between them. Anyone? What is the answer? Quick. Though identical metal plates, charge are same Q1, Q2. If they are now brought close together, what will be this? Anyone? Quick. Jaldi, sir. Jaldi. Anyone? Group में conductor का recording I had given ना? This was conductor recording sent in group? Now say no. No, sir. We didn't get conductor recording. The conductor recording wasn't sent in group. Anyone? Ki sent হয়েছিল তো নাকি conductor recording in the group? Yes or no? Probably 3 recordings of conductor was there. Why the conductor recording was given in the group? So that you can see the notification. That's it. उसके बाद सिर्फ अरे वही तो काम है ना. Once I send the recording in group, the only thing that you have got to do is notification देख लेना. Finishing the recording, making a proper active recall from that, that's not important. ठीक है, that's not necessary. Notification आ गया था, check कर ले दोस्त. If you want just want to verify, check कर ले your respective groups, it was sent. ठीक है. But in case of conductor, did we study if I'm giving Q1 charge to one plate, Q2 charge to the other plate, did we see something like this कि दोनों plate का ही outer surface में the charge used to be same. And what was that? Q1 plus Q2 by 2. Q1 plus Q2 by 2. Yes or no? Yes or no?
Q1 minus Q2 by 2C হবে answer.
Anyone else other than first tell me guys, दोनों प्लेट का outer surface में कितना चार्ज था? Q1 plus Q2 by 2. इसका inner surface में how much charge I used to have? अच्छा, Q1 is greater than Q2 or Q2 is greater than Q1? Q1 is greater than Q2. तो how much positive charge will be here? इसमें आएगा Q1 minus Q2 by 2. How did I know it's positive? Because question में given Q1 is greater than Q2. The two facing surfaces will be having charges of equal magnitude but opposite sign. तो इसमें charge कितना आएगा? In this one, इसका exactly negative. So Q2 minus Q1 divided by 2. Yes or no? Anyone confirm me once? Have we been able to draw it rightly? But does it matter to us how much charge is present on the outer surface of the two plates? No, right? We had already done enough problems when we had proved कि outer surface में जो charge है, that doesn't determine the capacitance. ठीक है? So can I just assume कि the charge is present only on the inner surface? I can ignore the charge on the outer surface? Yes or no? Please confirm me. I am not saying the charge is not present on the outer surface, right? The charge is there. But we had explained this previously and we had made a conclusion कि outer surface में जो charge है, that is not going to determine that's not going to determine what? That's not going to determine the capacitance. So for the sake of capacitance calculation, I can ignore the charges which are present on the outer surface. Is how much positive charge was here? Q1 minus Q2 by 2. How much negative charge is here? Q2 minus Q1 by 2. Guys, what is the formula for capacitance in terms of charge? Is it Q by epsilon naught? Yes or no? Is it Q by epsilon naught, guys? Absolutely no. Not Q by epsilon naught. Guys, what is the formula for charge? My goodness. Q equal to CB. আরে আবার ভাবছিসটা কি? আরে charge on the capacitor equal to C into B. What is the charge on the capacitor in this case? The charge on the positive plate. What is the charge on the positive plate? Q1 minus Q2 by C. This is the charge on the positive plate of the capacitor. The charge on the positive plate of the capacitor equal to capacitance of the capacitor into the potential difference between them. So what is the potential difference between them? Q1 minus Q2 by 2C. Yes or no? Any doubt? If you have got any doubt here, please to ask. Okay. For the calculation of capacitance, we can ignore the charges present on the outer surface of the two plates. This is something we had concluded in during our foundation sessions. I am not saying there is no charge on the outer surfaces. We have Q1 plus Q2 by 2. But we had observed this as there are equal charges present on the outer surfaces. We had made this conclusion during our foundation sessions that that charge is not going to determine the capacitance of the system. So for the sake of capacitance calculation, I'll be only considering the charge which is present on the inner surface of the two plates. How much charge is present on the positive plate then? Q1 minus Q2 by 2. Why? Because Q1 is greater than Q2. Charge equal to capacitance of the capacitor multiplied by the potential difference between the two plates. That's it. ठीक है दोस्त? Yes or no? Oh, the next one is a cakewalk problem. We had done this problem in class only. This is the easiest of this kind of problem. Do I need to do, or I can assume that you can do on your own? Can I assume that you can do on your own? Anyone? Can I assume this that you can do this on your own? क्या मैं ये assume कर सकता हूँ दोस्त? Please confirm me. Anyone solve this? I'm giving you 1-2 minutes. Solve this and let me know what you are getting. Quick. What will be the answer? Please confirm. Oh. Done. Quick. ठीक है? चलो. Again, I don't know how much. I have got. Obviously, I do have idea, but some of you are not that good with calculations. So I'll be not skipping any step. I'll be doing all the steps anyway. But anyway, चलो let's solve. अच्छा एक काम कर लेते दोस्त.
So ds
A epsilon naught by d ये जहां जहां आएगा ना, Orgodif, I'll be replacing this by C naught. जहां this thing will appear ना guys, I will be assuming epsilon naught d को मैं C naught से replace करूंगा. ठीक है? Now, Babu, this is one capacitor plate. Hopefully, I don't need to explain कैसे. Those days are gone, kids. ठीक है? इसका capacitance क्या मैं C1 मान सकता हूँ? Yes or no? Can I assume it's C1? Is this another is this another capacitor? इसको मैं C2 मान सकता हूँ capacitance. और इसको मैं C3 मान सकता हूँ. अच्छा, C1 and C2 connected in series parallel, or they are connected neither in series nor in parallel? C1 and C2 are connected in series parallel, and so C1 and C2 are connected neither in series nor in parallel. Anyone? Quick. C1 and C2 are connected in series. C1 and C2 are connected in parallel. C1 and C2 are connected neither in series nor in parallel. Quick guys. Anyone other than Orgodif? C1 and C2 parallel আছে, series আছে, or it is connected neither in series nor in parallel. Orgodif? Series na parallel connected আছে. C1 and C2?
neither in series not in parallel. আমরা C1 C2 বলতে পারি না, ওখানে C3 টা লাগবে।
তাহলে C1 and C2 আমাদের সিরিজে তো নেই, ওটা নিয়ে তো কোনো ডাউটই নেই আমাদের। Guys, is anyone of you thinking in this direction ki C1 and C2 are connected in parallel? Anyone is thinking C1 and C2 in parallel? Those of you who are thinking C1 and C2 in parallel, can you give any justification of this point? If C1 and C2 are in parallel, then whatever the potential at this point, same has to be the potential at this point.
কিন্তু dielectric constant আলাদা।
And how did you know? Is there any logic behind this assumption? If whatever is the potential here, same is the potential here. Those of you who are thinking ki C1 and C2 are in parallel, they are by default assuming, acha, ek side to same potential mein hai. So this two will be having the same potential based on which logic, sir? And this is something that we had spent sufficient time on during our foundation session. Ki this point and this point need not be in same potential. We had in fact proved this. और जिसका थोड़ा सा भी कॉमन सेंस है वो बोलेगा सर वी नो दिस सर कैसे सर here and here electric fields are different in these two yes sir here I have the same potential sir yes so sir here the change in potential will be electric field into d by 2 here the change in potential will be electric field into d by 2 और दोनों में इलेक्ट्रिक फील्ड है तो डिफरेंट इनसाइड में तो सर दिस पॉइंट एंड दिस पॉइंट विल बी प्रेजेंट इन डिफरेंट पोटेंशियल्स राइट तो ऐसा गलती मत करना दोस्त कि K1 और K2 को पैरेलल में ले लो ठीक है बट स्टिल सम पीपल आर shameless enough कि even after doing foundation sessions they are still doing this silly mistake that I had almost said billion times if I'm not wrong कि this is a possible silly mistake मत करना लाला फिर भी some of you will be doing the silly mistake मेंस में जाएगा गलती करके आएगा फिर बोलेगा ये ना सर probably क्लास में नहीं हुआ था सर ठीक है shameless people completely दो
স্যার আমাকে কি 10 K3 টাকে ভাগ করতে হবে দুভাগে?
আসছি দাঁড়া So one thing I can observe कि this one and this one are neither in series nor in parallel. अगर मैं पूछूं K3 किसी के साथ सीरीज और पैरेलल में है क्या? Probably some of you will be thinking, sir I ना मतलब cannot say directly. मैं पूछूंगा क्यों? अब बोलेगा सर if somehow I could get the equivalent of K1 and K2, probably उसके साथ I could have told in series. लेकिन sir I don't know how to get the equivalent of K1 and K2. K1 and K2 are neither in series nor in parallel. So I cannot think in that direction. Achha, what if I think in this direction that Spondon had just insisted and Orgodeep has also done because he has got the right answer. Let's imagine that this is split in two parts. इसको दो पार्ट में ना डिवाइड कर देते दोस्त इसको दो पार्ट में डिवाइड कर देते ठीक है और इसका पोटेंशियल सॉरी कैपेसिटेंस C1 इसका मान ले C2 or if I divide it into two equal parts can I say if this will be having a capacitance C3 the other half will also be having a capacitance of C3 only now can you draw the equivalent ladies and gentlemen now tell me C1 and C3 are connected in series so can I replace C1 and C3 in series connection yes or no C2 and this C3 are they also connected in series sir yes sir C2 and C3 are also connected in series and hopefully I don't need to explain that the equivalent of C1 and C3 will be present in parallel with the equivalent of C2 and C3 yes or no clear now can you do it on your own hopefully I don't need to do anymore কি পারবি তো এবার নাকি বল বাবা এবার হবে সলভ what is C1 equal to a হবে না a by 2 হবে C1 এ only this much part is there যে a by 2 টা প্রবলেমে কোনটা লেখা ছিল রে a by 2 আচ্ছা এক একটার a by 2 ই তো দিয়ে দিয়েছে আচ্ছা তাহলে তো ভালোই হলো তাহলে এইটুকু পার্ট কত হবে a by 2 the area of this part area বলছি area of this part is also a by 2 চলো আমার সাথে লেখা এক এক করে বল what is C1 equal to a by 2 into epsilon into K1 divided by what is the separation between the two plates of C1 I can say can I say d by 2 d by 2 have I written it rightly guys yes or no 2 gets cancelled but what did I say jahan jahan a epsilon naught by d aega I'll be replacing that by C naught so it's C1 coming to be C naught into K1 anyone confirm me once is C1 coming out to be equal to C naught into K1 or Gudif asche C naught into K1 if I make any kind of silly mistake please watch me immediately C1 is coming out to be C naught K1 everyone is getting this What is C2 equal to? Will it be C naught K2? Do I need to do? Am I connected? Am I audible? Hello.
Yes, sir.
ठीक है. But what about this one? Do I need to do, or I can directly write this C naught K3? এটাও কি হবে? এটা তো same. Will it be C naught K3? Yes or no? Quick guys. ঠিক লিখেছি? Yes or no? Quick. ঠিক আছে? Both C1 and C3 connected in series. What will be their equivalent? C1 into C3 by C1 plus C3. Yes or no? Will it be C1 into C3 by C1 plus C3? কি তাই তো বাবু আমি অ্যাজিউমিং যে ভ্যালুগুলো লিখে নিয়েছিস কি হয়েছিল বল C0 স্কয়ার ইনটু K1 ইনটু K3 বাই ডেনোমিনেটরে কি ছিল C0 K1 plus C0 K3. C0 কমন নিলে I'll be getting K1 plus K3. Is this what I'll be getting? Can I cancel one C0 guys? So the result will be C0 K1 K3 by K1 plus K3. Yes or no? C0 K1 K3 by K1 plus K3. Yes or no? Oh, do I need to do the other side, or do I already know? In place of K1, I'll be writing K2 this time, right? So this two can be replaced by a single capacitor of capacitance C0 K2 K3 by K2 plus K3. Yes or no? Have I been able to do it rightly? The two are connected in parallel. What will be their equivalence, sir? Do I need to just add the two? So C0 K1 K3 by K1 plus K3 plus C0 K2 K3 by K2 plus K3. Babu, instead of using this multiple capacitor, if I replace the whole system by a single capacitor, which is filled with having the same capacitance C. It is true. What will be if I assume the dielectric constant present here is, let's say, K? Then what will be the capacitance of this? Anyone? What should be the area? Should I write A by 2 or should I write A this time? I am replacing the whole combination by a single capacitor. So should I write the area equal to A by 2 or should I write the area equal to A? I should write the area equal to A. Taito? I am replacing the whole by a single capacitor. So if I replace the whole thing by a single capacitor, इस पूरे का area क्या होगा? A into epsilon naught into dielectric constant I have assumed K by what is the separation between the two plates? D. So this result that I key, right? Everyone, A epsilon naught by D. Did we assume this is C naught for us? So am I getting the result C naught into K? So this equivalent that I had got, can I replace this equal to C naught K? C naught can be cancelled from all of them. K equal to, take K3 common, I'll be getting K1 by K1 plus K3 plus K2 by K2 plus K3 whole multiplied by K. D is the answer. Any doubt, sir? Yes or no? Is it clear, guys? Have you been able to understand till now? Any doubt? Good. Can we move to the next problem? Okay. Well, if you have got any doubt here, please do ask. If you have got any slightest of doubts from this problem, why these two are in series, why these are in parallel, or questions like this, why are these two not in series, not in parallel, neither in series nor in parallel, please do ask. Okay? If you are not asking doubt, it's your loss only. Okay? So exam में जाके आप ही गलती करके आओगे. If you are hesitating here, you will be hesitating for the rest of your life when people will be asking what was your rank in JEE Mains. तो अभी पूछ ले बेटा, अभी hesitate मत कर, अभी पूछ ले. I am not going into detailed मतलब description of each and every point because this is not a foundation session. This is a revision that we have started from today. These are the level 1 problems. So I'll be assuming there is something that you have already learned. Okay? I will not be assuming that I have to solve each and every problem from the scratch. A capacitor of capacitance C is charged to a potential difference V. Acha, and then disconnected. See guys here, look at this. Here they have mentioned specifically that after charging it has been disconnected. So if there is a capacitor of capacitance C, if you charge it by a potential difference V, What will be the plates? What will be the charge on the plates? Anyone? One will be having plus CV. Hopefully, I don't need to explain explicitly. The other will be having minus CV. And now you have disconnected. I go. You have disconnected it now. Babu, if you disconnect, will there be any change in charge? No, no, sir. There will be no change in charge. But they are saying that a charge plus Q is now given to its positive plate. They are saying, I am not saying. They are saying that a charge plus Q is now given to the positive plate. So what is the total charge present in the positive plate? Q plus CV. What is the total charge in the negative plate? Minus CV. Q. Because after charging, you have disconnected. So there shouldn't be any more change in charge, but explicitly they have mentioned that there is a charge plus Q now that you are giving to the positive plate. So already CV charge tha positive plate mein, and you are giving a charge of Q. So what should be the net charge in the positive plate? Q plus CV. What is the charge in the negative plate? Minus CV. Now my question is, can you tell me, ladies and gentlemen, how much charge will be in the outer surfaces or in the inner surfaces? Did we study something like this in our conductor sessions? If Q1 charge is given to the one plate, Q2 charge is given to the other plate, outer surface may just in the last problem only we had discussed. What is the charge in the outer surfaces of the two plates? Q1 plus Q2 by 2. Here Q1 is Q plus CB, Q2 is minus CB. दोनों को ऐड करूंगा, Q1 plus Q2 तो Q आएगा. So Q by 2. दोनों प्लेट का आउटर सरफेस में you have charge Q by 2, Q by 2. Clear? Now. अब बोल इनर सरफेस में कितना होगा? अब बोलेगा सर कॉमन सेंस. भाई कॉमन सेंस है नहीं मेरे पास, आप बताओ. अब बोलेगा सर देखो, here the total charge was Q plus CB. आउटर सरफेस में ऑलरेडी Q by 2 है, तो हाउ मच चार्ज शुड बी प्रेजेंट इन द इनर सरफेस? पूरा से Q by 2 को सब्ट्रैक्ट कर दो, सो यू विल बी गेटिंग Q by 2 plus CB. ठीक है दोस्त? Two facing surfaces, the two surfaces which are facing each other, they will always be having charges equal in magnitude and opposite to that in sign, right? So how much charge is supposed to be in this plate? Minus of this, so it will be minus Q by 2 minus CV. And if you are in doubt, sir इस plate में total charge क्या minus CB है? Add करके देख. Inner surface में minus Q by 2 minus CB, outer surface में plus Q by 2, so total charge is minus CB. So I am doing in the right path now. Babu, did we see something like this? Ki while calculating the capacitance, the charge on the outer surface doesn't matter. So whatever is the capacitance of the capacitor, that will be equal to charge on the inner plate by potential difference. What is the charge on the inner plate, guys? Q by 2 plus CB. Sir, why not minus Q by 2 minus CB? Babu, when I say charge on a capacitor, I mean charge on the positive plate of the capacitor. What is the charge on the positive plate of the capacitor? Q by 2 plus CV. Sir, why you are ignoring the outer surface? For the last time I am saying, for writing capacitance, we had explained this. Ki charge on the outer surfaces of the two capacitor plates can be ignored. So only consider the charge on the inner surfaces. एक में है Q by 2 plus CB, एक में है minus Q by 2 minus CB. By charge, I mean the positive charge. So it will be Q by 2 plus CB. What is the question, by the way? The question is find the potential difference. मतलब they are asking the value of एक second have কিছু একটা গন্ডগোল হলো, কি গন্ডগোল হলো বলতো? Q by 2 plus CV. There is some silly mistake that I have done. C equal to Q just acha sorry, मतलब the two V are not same. First of all, this V that I have written, this V is the potential difference of the cell, right? And potential difference across the capacitor, I'm assuming this is V prime. तो कैलकुलेट कर लो, V प्राइम इक्वल टू क्या आ रहा है? V प्राइम इक्वल टू इसको डिवाइड कर दो Q by 2C, CV by C will be V. So answer should be Q by 2C plus V. ठीक है? Any doubt? Anyone? Please to ask. Slightest of doubt भी है तो पूछ लो बेटा. If there is any concept which is not in agreement or not in conformity with what you had already learned, if you feel that there is a disparity between the two, please do ask. Do not hesitate today. Okay? The other two batches literally আমাকে পাগল করে দেয় by asking doubts in the class. This is the only batch जहाँ एक भी doubt नहीं आता है during the sessions. ठीक है, चलो. But anyway, let's come to the next. In a given circuit, কি বলেছে? When switch S has been closed. अच्छा. Then charge on capacitor A and B. क्या problem guys? Solve and let me know. क्या आएगा? In the given circuit, अच्छा, this 4Q I think it was supposed to be here, I guess. Anyone, if you close this, क्या आएगा? Quick. Initially, you have a total 3Q charge in this plate. मतलब this one is having 3Q, this one is having 6Q. ताई तो नहीं, if I'm not wrong. Yes. ताई तो बोला chief. Okay. बोल बेटा. Once you connect them, क्या आएगा? Initially, मतलब before it was closed, 3Q charge was present on this plate, 6Q charge was present on this plate, and now you decide to close the switch. The question is, what will be the charges on the capacitor? तो अब मुझे पूरा charge distribution बता दो कि क्या होगा. This is the most basic problem. We had done multiple problems regarding charge distribution in this batch, but शर्म नाम का कोई चीज होता है जो probably बहुत लोगों का डिक्शनरी में है नहीं. That is the problem. Anyone else? बाबू, मान ले कि after you close the switch, let's assume after you close the switch, लेफ्ट वाला में चार्ज होगा मेरा Q1 और राइट वाला में मेरा चार्ज होगा Q2. Let's assume, ठीक है. मतलब you know, like I had been solving this in the other batch. Probably Oniket does the recording. I'll be sending the recording of the other batch in this group. Literally, they had been asking doubts and very genuine, very nice, fundamental doubts in each and every problem. Well, there are students who actually know the answer, but just to be 100% sure, they sometimes ask the doubt. Well, there are students who knows कि मतलब they are 99% sure that they know the right thing, but just to check whether they are thinking it rightly or not, they do ask doubts in each and every problem. मतलब to put a पूरा horoscope we get out of this in both the two batches. I'll be sending the recording of one of the other batches. एक बार देखना. You guys literally didn't ask a single genuine doubt out of. तो अब दो केस हो सकता है. एक तो हो सकता है you understand everything, which is very unlikely, and the other possibility is that you know what I want to say. मान ले after the two are connected, इसमें आएगा Q1, इसमें आएगा Q2, तो इसमें कितना आएगा -Q1, इसमें कितना आएगा -Q2. Yes or no? Clear? Babu, look at this plate and look at this plate. ये दो plate, are they connected by a pure conductor? Yes, sir. Are they collectively isolated from the rest of the network? Look at this plate and look at this plate, guys, and confirm me. These two plates, are they collectively isolated from rest of the network? Yes, sir. So the sum of charges in these two plates should be constant. What was the sum of charges in these two plates initially? 3Q plus 6Q equal to 9Q. So here also the sum of charges in these two plates, that is Q1 plus Q2, should be exactly same. I don't know why I'm explaining this. I had spent a single class on doing by just on these types of problems. The Q1 plus Q2 will be 9Q. Second, are they connected in parallel now? Yes, sir. So whatever is the potential difference across this, same should be the potential difference across this. Or you can just write a KVL across the row, whichever you find to be better for you. So Q1 by C1, what was the capacitance here? अच्छा, हाँ, it was given, sorry. इसका कैपेसिटेंस था 6C और इसका कैपेसिटेंस था 3C. तो Q1 by 6C should be equal to Q2 by 3C because the potential has to be same. Or if you are struggling with this, you can just write a KVL. Which one makes you more comfortable? You can do using that approach. What is the potential difference from here to here? इधर से इधर आऊंगा तो कितना चेंज होगा पोटेंशियल Q1 by 6C. If I move from here to here, what will be the change in potential, sir? Should it be Q2 by 3C, sir? So am I getting Q1 equal to 2 times of Q2? Yes or no? Clear?
हाँ
बाबू पुट कर दे here Q1 equal to 2Q2, तो 3Q2 तो Q2 equal to क्या रहा है दोस्त? 3Q and Q1 is 2 times of Q2, so will it be 6Q? अच्छा, what was the question? अच्छा, just on the charge, A में 6Q, 3Q, so this is the answer, guys. Yes or no? Quick. Is it clear, guys? Yes or no? ठीक है? Does it make sense? चलो सर्किट वाला प्रॉब्लम आज कर लेते हैं, ठीक है? Let's solve 2 more problems. I know some of you are having practical exam tomorrow. Acha, I'll be having a small session in Saturday night as well, okay? Because I have to finish this. So let's solve 2 more problems today. Then rest of the problems and few more problems we'll be doing Saturday night. I'll mention the exact time in group. বল আগে কোনটা করবি? সেম ওয়েতে করবি নাকি সেম অর্ডারে করবি, or you want to solve the circuit problem first? Let's do the circuit problem, huh? We all enjoy doing this. This is a cakewalk problem, guys. Do I need to solve this in class? मत बोल. So this is not a problem. We had done literally each and every asymmetrical circuits. ये क्या है सर? 12 and 6 are they connected in series? Equivalent क्या आएगा दोनों का? 12 into 6 by 12 plus 6, 4. 4 and 4 are connected in parallel. So what will be the equivalent of all of this? 8. 8 and 2 are connected in. अच्छा दाड़ा wait कर. First let's come to tale in this particular key 8 and 2 are connected in what, by the way? Let me draw it here.
series.
8 and 2 are connected in series. So what would be their equivalent? ये दो point के बीच instead of writing 8 and 2 I can replace by 16 by 10. 16 by 10 is
8 by 5.
8 by 5. What about this side? 2 and 2 are connected in series. Equivalent 1. 1 and 1 connected in ये part 1. 1 or 1 connected in parallel. Equivalent
Parallel.
is 2. 2 and 8 are again connected in series. So equivalent is same 16 by 10.
8 by 5.
So again 8 by 5. 8 by 5 and 8 by 5 connected in parallel. C और C अगर parallel में होता है तो equivalent क्या आता है? C by 2. So 8 by 5 and 8 by 5 in parallel will be giving me 4 by 5. Acha, what was the question, by the way? Acha, they have said that the equivalent capacitance is 3. Very good. So C and 4 by 5 are connected in what? Parallel? No sir, series. इसका मतलब 1 by C plus 1 by 4 by 5, which is 5 by 4, will be equal to, check करो नहीं if I'm making any calculation error, will be equal to 1 by 3. Yes or no? Anyone confirm me once? তাই তো নাকি?
ওখানে তো দুটো ক্যাপাসিট্যান্স প্যারালালে ছিল।
এক্স্যাক্টলি, তো সেটা এতক্ষণ পরে বলছিস কেন? আই ওয়াজ জাস্ট ওয়েটিং কি যদি কেউ বলে আমাকে। তো এতক্ষণ পরে সেটা তাহলে কেন বলছিস?
ওই আমি একটু ভেবে তারপরে বললাম।
তারপর একটু ভেবে ভেবে ওরে বাস, কত ভাবতে হয় না এটার জন্য। Anyone, what will be the equivalent then of this part?
16 by 5 হবে।
8 by 5 and 8 by 5 are in parallel, guys. कैपेसिटर पैरेलल में ऐड होता है दोस्त. So equivalent क्या आएगा? 16 by 5. तो इधर एक C था and the equivalent of this whole damn part is 16 by 5. तो C and 16 by 5 are connected in what? Series में.
Series.
इसका मतलब 1 by C plus 1 by 16 by 5, which is 5 by 16 equal to 1 by 3. কি আসছে ক্যালকুলেট করলে এটা আমাদের? কি অ্যানসার আসছে না? 16 minus 5. দাঁড়া, কোথাও ক্যালকুলেশন মিস্টেক হলো নাকি আমাদের? চেক দ্য ক্যালকুলেশন ওয়ান্স। 6 and 12 হচ্ছে আমাদের 4, 4 and 4 হচ্ছে 8, 8 and 2 হচ্ছে আমাদের 16 by 10, মানে 8 by 5 ই তো। Please, did we make any calculation error?
স্যার অপশন 2 আসছে।
অপশন 2 আসছে।
ও আসছে, আমি দেখি।
হ্যাঁ 48 মিনিট।
ও সরি আমি 48 টা মিস করে গেছি। আমার তো অন্য কিছু আসছে। ও না এই তো
16 minus 15।
ও আমি দেখিনি 48 মাইক্রোফ্যারাডটা, সরি আমি বাকি তিনটে দেখছি। 48 is there, 48 microfarad is answer. Guys, मतलब are these problems मतलब which are supposed to be solved? No, मतलब this is not even level 1. चलो बाकी भी कर लो मेरे साथ. 2 and 2 connected in series.
series.
तो इन दोनों का इक्विवेलेंट क्या आएगा? 1.
1
This one and this one are connected in parallel.
parallel.
So instead of this whole damn part, can I just imagine as if there is a 2 microfarad here? This 2 and this 2 are connected in series. Anyone? This 2 and this 2 are connected in series. So
हाँ,
इन दोनों का equivalent क्या होगा? Again 1. So
One.
instead of this whole damn thing, can I just think there is a 1 here? This 1 and 1 are connected in parallel. So equivalent will be
2 में.
ठीक है दोस्त, कैलकुलेशन चेक कर लेना. चलो लेट्स सॉल्व वन मोर. हाँ, क्या क्वेश्चन है? द टोटल है बेकार क्वेश्चन. टेल मी 6 and 3 are connected in anyone quick guys?
Series.
Series equivalent 2 की इन दोनों का 2 होगा ना. 2 and 2 connected in parallel. So
Parallel.
equivalent is
1
equivalent is
4
1. 1 no 4.
4
So it will be 2 volt. इसके across में I have connected 4 microfarad. Babu, how much energy, sorry, how much charge will be delivered by the positive terminal of the battery? Acha, instead of just think in this fashion, the equivalent capacitance is of 4 microfarad. What is the potential across the equivalent capacitance? 2. So what will be the energy stored in the equivalent capacitor? Half into equivalent capacitance into V square. Yes or no? Am I getting 8?
हाँ,
Is it 8 guys? Am I getting 8? Anyone confirm me once? अच्छा, ये जूल में आएगा, नॉट इन माइक्रोफैरड. एनर्जी जूल में आएगा. बाबू, whatever is the energy stored in the equivalent capacitance, can I say that is the energy stored by the whole capacitor system? So what is the energy stored by the whole capacitor system? 8 microjoule. Is it clear guys? Chalo, we'll be starting from here on which day? Saturday you have a small session. So Saturday में हम 13, 14 and how many are left here? 18, 19 ये चार करेंगे. Then we'll move to 10 problems of level 2. ठीक है? How many have we solved today by the way? 12. उसके बाद 13, 14, 15. 15 we have done in class, right? So after finishing the rest of the part, there will be I think 10 to 12 problems in level 3. Sorry, level 2. Then there will be 10 problems in level 3. If you can finish all of this by the next Tuesday session, this chapter for mains and NEET is done. Again, advanced के लिए this session is not. ठीक है, this session is not for advanced. Advanced के लिए we are already having other sessions, but I am not sure कि if anyone will be fitted there at least for now. So I'm waiting for some of you to get upgraded to that batch. I will see the result of first mains, and based on that, I'll be upgrading some of you. But this session will go on as it is. But some of you will be probably upgraded to another session as well, completely depending on the score of first mains. So the topic which are purely for advanced will be doing there. The problem which is supposed to be for advanced will be doing there. But the 3 level of problem, level 1, level 2 and level 3, if we can finish this by the next week Tuesday, this chapter will be prepared for mains. ठीक है, उसके बाहर से mains में कुछ नहीं आएगा. All problems that we had been doing today, they are the level 1 problems. ठीक है, चलो, thank you guys, you can leave.